do is D port equal to AD, right? Just trying to kind of quickly check like if this time it will work or not. Okay. And packet equal to IPP and TCP. So we have the packet, and now what we'll do is we will send the packet. Let's see if this work. I hope this was working. I don't know why. I think it requires rootless. So let me just try this out this time and enter. Oh, really? So guys, so we have sent out our one packet in the real world that we have crafted on our own, right? And let's see if it shows up. And if you see, this actually shows up over here, right? So what you see is that, and what we can do is that you can kind of have some more fun with this. So if I send again this packet, if you see, it shows up in the wire socket. So this is a proof that two things. First is to run the SCAPI, you need root privilege. And because thing is that it sends the packet, it has to do a lot of things in the background because for the normal user, the system won't allow you to kind of send this crafted packet by default. Okay, you need to kind of set your interface in promiscuous mode. Actually, once you set the interface in promiscuous mode, then only the operating system of the computer will allow you to send any packet outside, and the SCAPI does all this thing in background for you. And if you see, this is the packet that we have created, right? So it has the IP header. IP header, if you see, it is all good. There is no issue with the packet. If there would have been any issues, thing is that the wires are going to be telling that it is a wrong packet. Okay, so if you see, all these values has been fulfilled via the SCAPI for you, right? And the source address that we have given and the destination address that we have given. Similarly, source port and destination port, where we see source port is this, destination port is the 80, right? And this is what we are seeing over here, right? So what we do is that now, we let's say we create a packet, we send the only the IP, a packet with the only with the IP header. Okay, let's see if it goes. Okay, so it says that, okay, now you see it's an IPv4 packet, and what you get is only the 3 layers, the Ethernet header, 2 layers Ethernet header, and the IP header over here. Okay, because we have only sent out the IP header, not the TCP header, right? And in similar way, if we just sent out the TCP header, let's say, and it says it sent one packet, okay, and now if you see this one, this is the actual packet that we have sent right now, okay, but the Wireshark was not able to parse it. The reason for that, as you remember, we have added the TCP header, but we haven't added the IP header, and that's why the packet was like, what do you say, is a wrong one. And that's why thing is that the Wireshark is not parsing that properly. Okay, to add the TCP header, we need to add first the IP header, then only that packet will look correct one, will be a correct one. Okay, so in similar manner, what we do is we send this packet, and if you see, it will show that, okay, it's a TCP packet with everything in detail. Okay, now thing is that what we can do is let me do one thing. Okay, so I hope till this point it was clear. We'll try to kind of now, so this was the only thing that what we are doing over here is we are actually understanding how to write an injector. Okay, so we are injecting the packets, we are crafting the packets, and then we are kind of injecting the packets on the wire to the real world actually over here. It's not something in lab. That packet actually went outside. And the thing is that now what we'll do is let me do one thing. Do one thing. This time, I will change the TCP packet destination port to 53. Okay, and let me see if I'll just create the packet. And let me just send the packet. And if you see, it actually send the packet outside and with a lot of details over here. So now if you see guys, if I again kind of start the screen, so this time what we will do is that we have changed the destination port to 53. 53 is for the DNS packet. All right. So what we'll do is we'll send the packet. And if you see, we actually got the response from 8.8. So we are actually seeing that our packet went to the real world to the Google DNS server, and then the Google DNS server responded to us based on the data that we have kind of forwarded to that DNS server. So we requested something over port 53, and actually that IP address over port 53 responded back to us, okay, with some details. The reason is that here the Google DNS server is telling me the conversation complete is incomplete. The conversation is incomplete because normally in the DNS packet, what we do is that we query a website address, and thing is that here because it was not having that website, we were not querying any kind of like, let's say, any kind of website, and that's the reason the Google DNS server is telling me that the request that was made to the Google DNS servers is incomplete. Okay, and then you see is that our own operating system actually send out a reset packet telling that to reset the connection. There is no data will be kind of sent out for this session going forward. Okay, so this packet was handled by the operating system where it's already sent out a reset packet, and this packet was sent out by me. This was received by Google Data Server, and this was sent out by the operating system. So let me just quickly do one thing. Let me do one thing for you guys. Mhm. Okay, so what we will be doing is now we will be kind of, let's say, we'll actually create a DNS packet. Okay, and let's see if we get a DNS response. Okay, so what we will do is we will try to do something like this. First, we need to kind of import all the required modules from the SCAPI. So let's say we need the IP header, and what we'll do is that this time we will, since we are utilizing DNS, so we'll do that over UDP, right? So rather than the TCP header, we need the UDP, like we will kind of utilize the UDP protocol. Okay. Then what we'll do is that we will, since we are utilizing DNS, so we'll involve a DNS module and few other modules for us. And let's say, and this is SR1. I will explain what SR1 means. SR1 actually means that send the packet. It's a different way of sending the packets. There is a one minor difference. I will explain that later. What SR1 means and SR. What there are two things, SR and SR1. So I'll try to explain that later. But overall, it's basically related to kind of sending out the packet. Okay. So we imported all these modules successfully, and what we'll do is that we'll quickly create a packet, and where the packet will kind of go to this destination, again the Google DNS server, right? And we'll create a UDP packet. So what we'll do is that we'll write UDP equal to UDP header rather than TCP. We did UDP, and we say destination port is equal to 53, right? And what we do is, if we do UDP.show, it will show